So question 13. Triangle ABD is a right angle triangle at B with angles BAC equal to P and BAD equal to Q and lengths as shown in the diagram below. So we're asked to show that the exact value of cos Q minus P is equal to 19 root 7 all over 85. Okay, so might look spooky at first, but don't worry, it's going to be fine. So what you might can spot here is actually two triangles in here, and then using those two triangles we're going to get some more information about what we need to do. So first of all, I'd suggest I start off by sketching these two triangles. Okay, so that's the first one. That's got length 4 and then 1. So using Pythagoras, it's going to square root of 4 squared plus 1, which is going to give me root 17. And then over here we'll have the slightly bigger one, which is going to be here. And then you've got a length 4 here, then you've got a length 1 and then 2, so that's 3. So 3, 4, 5 right angle triangle. Cool. And then angles here, we have angle Q in here, and we have angle P in here. Awesome. Right. So what we can do now is we can get the values for all the different, well, let's actually think about it this way. This way first might make more sense. So we've been asked to work out what the cos of Q minus P is, right? So cos Q minus P. Okay, so how are we going to work that out? Well, we actually have a formula for this in our formula sheet, which will come out to say cos Q cos P, and because this is a minus, this becomes plus, is sine Q sine P. Okay, well, actually we're using trigonometry. We can actually have values for all of these expressions. So just using SOHCAHTOA, we can work out all the things we need to know. So sine of P, well, we just need to look up here. Well, sine of P is opposite over hypotenuse. That's 1 over root 17. And then cos of P is going to be 4 over root 17. And then over here we have sine Q, which is going to be 3 over 5. And then we have cos Q, which is going to be 4 over 5. Okay, so now we have everything we need to go into that expression. So it's just a case of just subbing it in. So cos Q minus P is equal to, well, cos Q, so 4 over 5, times, and then it says cos P, which is 4 over root 17, and then plus sine Q, which is 3 over 5, and then sine P, which is 1 over root 17. Okay, so let's multiply these out. So you get 16 over 5 root 17 plus 3 times 1, which is 3 over 5 root 17. Okay, well, that's easy enough because those have the same denominator, so they'll add together. So you get 19 all over 5 root 17. Okay, so you might be thinking, okay, is this my final answer? But actually, if you look, they say they want to show that is the exact value of this here. Okay, so how can we show that these two numbers are the same number? Well, what we can do is we can use this to rationalize, we can use this technique to rationalize the denominator. and we're just going to times both sides by root 17, both the top and bottom. So root 17 and root 17 is just 1. So we're basically just timesing this whole expression by 1, but by doing this, it actually helps us express the equation in a rational way. So we end up with 19 times root 17 is just going to be root 19 root 17 as expected. And what's going to happen actually when you times root 17 by root 17, you're just going to get 17. So you're going to get 5 times 17, right? Which looks a bit scary again. So remember, this is non-calculator. 19 root 17. We can just do a little aside. So you get 5 times 17. I'm not quite sure to do, but I could do 10 times 17. So 10 times 17 equals 170. 170 over 2, 85. So that is 85. And that's exactly what we were looking for in the question. Right, so there's the final answer. Okay. So a fairly long question, but we'll see where we get the marks. So you get a mark for getting the hypotenuse of these triangles, and then you get a mark for selecting this compound angular formula, and then you get a mark for calculating these sine and cos values. It's this one there, and then you get a mark for calculating the other two and substituting them with the formula. Okay, so like a mark here, I guess, for having them substitute into the formula. Then you get your last mark for arranging the expression into the correct form with a rational denominator. Here, so there's your 5 marks.